Hi, this is John again. Again, I'm with this Cypress PSoC 6 Pioneer BLE Pioneer Kit, and I've been going through a bunch of examples with this. This time, what I found a pretty cool example out on Sparkfun regarding how to connect this with the Raspberry Pi, actually communicate with BLE. I've done a couple of things with that as well, and I was just think it'd be cool to show that example as well. So I have a Raspberry Pi B over here with the code already loaded, and then I have the Pioneer Kit over here. I did some hacking of the graphics and come up with this little simple graphic right here, just to have a little display there. I try to use the tool that was listed in the examples, but that seemed to have a problem, the one that's shown within the examples from Cypress. It created a header which pushed the image over. It also put a watermark on there. So actually the image here I used from TI, the MSP graphic tool that they have. It generated code, it seemed to work, threw it inside there, and it seems to be working fine. So that's what we have there. So I have this example from the web page. This is coming from Sparkfun, their Learn web page, and it's using a PSoC 6 Pioneer board with the Pioneer IoT add-on card. So them and DigiKey came up with this add-on card for the Pioneer Kit, and it has the headers on here for an XB module. It also has a micro SD flash for data store, and then this quick connection right here where you can daisy chain this with other similar boards. I believe it communicates through I2C, and you can have this connect to sensor modules and stuff like that. So they have a series of those as well. I just found this recently. I don't think I have enough time to order this and get it and try it. I have some XB modules. I'm not quite sure if it will work or not. I could probably make it work. But the one I want to work on is this example here, BLE to Raspberry Pi. Actually, let me go back up here. So let's go through this. They have this is a pretty good example, man. They go through a bunch of stuff. They show something that you need for the Raspberry Pi, and they describe the module pretty good. They tell you for the PSoC 6 you need Creator 4.2, and then they have the download for the software here. So I've already done that. They also show you how to set up the networking for the Pi and stuff like that to get this up and running. But again, the one I'm interested in is the BLE to Pi down here. And another thing to note, this example here that they reference, I could not find. I could find a 133 and a 135, but I couldn't find that. So that's one thing to note. So you can go through GitHub, and then you can download this onto your Raspberry Pi, and then it's basically just run the script. The script's already set. They've hard coded the address on here for the BLE device, so it's going to be the same regardless of which one you have. So if you have two of them, you probably want to go in and change one of them inside the code for the PSoC code. And so it's a pretty simple example. And you also need BluePy, so you need to get that downloaded through pip, I guess, to get that in for Python. That's what they use for working with BlueZ with that. And so that's a couple of things. And then this is the thing here. So inside the code, they've hard-coded this address right here for the BLE address. So it's going to be the same. So you don't have to worry about changing that unless you've actually changed it on in the PSoC device. And then they show what the Python code is doing, how it's writing out. It's setting, enabling the characteristic, and then writing out. This is basically going to set all the LEDs on the RGB to 1, and it's going to make it turn white. Just to indicate that we have a connection. And so that's pretty much what that is. And one thing to note, after I downloaded the code and got it installed, I did run into an error. And what it was looking for was this eFuse folder under the generated source. For some reason, it couldn't move it over there. It was copying it from program, the program folder for Cypress for the PSoC, and PSoC Creator, but it couldn't load it. I don't know why. So I just took this and copied it over and then rebuilt, and that seemed to take care of the error. So that's one thing to note with this example. So I already have this up and running. I've already loaded the code and I've built it. And so this is coming out of the main for CM0. So that's a Cortex M0 code. And so they go through and unlock the devices, then disable it, and initialize RGB, initialize CapSense, because we're going to use that. This is going to use a CapSense to indicate button presses. And then they go through the BLE start. So this is kind of where all the main portion of it happens. And then their top level design. Let me go back over here. I'm guessing they used the BLE with CapSense example. So that's kind of what they've done. This is another thing I found interesting. Most of the examples I've seen just added like a digital pin here and did not include the rest of this circuit. I've tried this as well on one of the examples I had, and it seemed to work fine. Also, this I only saw with hardware, so I don't know if they're doing like a hardware assist. So I don't know if it's a different type of example. I need to do some research on that. So that's pretty much what they have. They got the BLE component, and again, I've already loaded that. So that's pretty much an overview of that. I'm gonna just go ahead and back and reload this. Shouldn't take long. We should get a blink when it happens. Sorry, there's some sun coming in. I don't know if that's gonna mess things up. It should flash. Maybe I need a faster USB connection. I would think it wouldn't take this long. So we'll let that go. I have a putty session that's already up, connected to, there we go, it was successful. So this is already connected to the Raspberry Pi. And we can just go ahead and use something like HCI tool, right? And then do like an LE scan. And there's our CapSense. There's our PSoC device right there. So there's the address that we're looking for. And so we can come out of this. And then if we go ahead and do something like GAT tool -I, connect, and then we want to connect to this dude. And we look at primary. We can see some of the characteristics with this, and then if we look at characteristics, I didn't spell it right. There it goes. So that's the rest of them. And so the 17 here should be for the RGB, and there's a 1D for actually enabling the device, which is not shown here, but it's within the range. So that's one way of collecting data off that, just to see what the characteristics. We know we're connected to the device, and you can't see it, can you? So I think, yep. Oh, you'll see it when the example happens. So let me get out of this. So we can actually use BlueZ. We can use some of the GAT tools and look at some of the values. So we can read to see if that handle was enabled. We can go ahead and write to it and then read it. They must have something else running on here, or otherwise I'm doing this wrong, because if we read it again, it's off. We can also set, let's go set the blue LED. I don't know if it's going to show up on this or not. There it goes, but it'll go away. Yep, it's not persistent. So we know we're connected. We can run some commands to it. So this is, again, running off the Raspberry Pi. So I've already loaded this in. So this is where once you get to GitHub, it'll create a folder, the Pioneer Kit shield, and then the software BLE. This doesn't require the shield. This just is basically a BLE test. And then they have a script inside here. We can go look at that. What happened? whatever. So they're importing from BluePy, the scanner, the default delegate, and all that stuff. They're also using RP GPIO to enable devices. And then this is basically their notification. So look for notifications, so look for button presses. It'll tell you where the button's on, button off, and then it covers both of them. And then the peripheral device, this is the device that we've seen before. And then these are the characteristics. So if this is all binary, so no decimal. If we convert that to hex, then this should be a 1D and this should be a 17. So that's what I shown before. And that's pretty much all it does. Oh. Sorry, keyboard problems. So if we go ahead and run this, there it goes. So it turns the RGB LED to white when it's connected. So we've got that indication. I think it's coming through. And then if we go over to the CapSense device, do some button presses, it indicates buttons on, buttons off. So 0, 0, 1, that one, and then that one. And that's pretty much all it does. So that's a quick example showing how to connect to the device remotely using something other than the SciSmart or, say, another mobile device or something like that. So, yeah, they haven't got the keyboard disabled on that to break out of it. So that's pretty much it, and that's a kind of cover what this Sparkfun example is covering for the BLE. If I can get some XB modules working on this, I'll try to do that, but I just have a couple more days for this and try to finish up. So there you go.